Okay. All right. Today we're just going to take a few notes. That's all we're doing today. I'm talking select few. The reason why I want to do about 3 problems or so, we'll kind of see. And then I'm going to give you some time to work on that assignment. That was your new one that you just had, the page 65. I'll put it back up here. That assignment is due tomorrow, so keep that in mind. I know some of you had a really good start on Friday, but some of you didn't. Maybe you tend to forget. It does happen over a weekend. But it's due tomorrow. It's based on difference of squares, cube rule, and grouping. So I know that some of them they can be kind of challenging, so I'll give you a little bit of time to work. My goal is to do 3 problems to intro the next section. Like the whole reason why we spent a long time, almost a week, factoring. Well, today we get to see it. It's based on functions, rational functions. So let's deal with that. So the section we're in P.8 now. I know we're still not prerequisite stuff, but it goes with chapter 1. I consider this chapter 1 stuff. They put it in the wrong section, but it's rational functions. Rational functions. Rational meaning fractions. Anything you can write as a fraction is a rational number. Well, these are functions, so they have variables in them. They have, they're polynomials. So what we're going to look at today, kind of the example we're going to do something with sum and difference. It's going to be kind of one of the problems we're going to look at. How do rational functions deal with addition or subtraction. We'll just do one. I'll kind of mix and match. We're going to do one with multiplication today.
I don't think it came from this one.
What is this one?
Yeah, I didn't realize I had that one on. I had it ready to go for Zooming later. I didn't realize I had it on already. And division. Okay, so these are the 3 problems I'd like to go through. Just kind of intro them. Just kind of go something kind of easy. But again, it's kind of one of those things, you just got to see one and see kind of what we're doing. Okay, let's talk about this. So here's the example I want to talk about. I want to talk about a sum or difference. Now, I'll let you guys choose. You want to addition or subtraction?
Addition.
Addition? Okay, we'll do that. We'll do a subtraction problem tomorrow. So we're going to do an addition problem with rational functions. Now, what I mean by that is we're going to have 2 fractions being added together. Now, I'm going to just kind of make up a problem here. Let's go with x squared plus 6x plus 8. And let's go with x squared plus 9x plus 20. And on the top, I'm going to go 3x minus 2 and x plus 5. Okay, this is a rational function. Do you see how there is parentheses, or not parentheses, but fractions being added together? And are the denominators exactly the same? Definitely not. This is kind of an ugly based problem. What we need to do is figure out how to add these 2 items together. And that's what we need to figure out. We got to figure out how to add the 2 fractions. This is something that pretty much all the classes leading up to pre-calc really struggle with. They just don't understand the simplicity of it. How do you add fractions together? What's the easiest way to do it? How do you do it when there's like variables and crazy numbers in them? All right, so let's just kind of walk through the basics here. Here's how I always explain it. When you add fractions or subtract, you need to make sure that they're in the same terms, like the same denominator. So the book refers to it as a common denominator, right? Common denominator. But I think of them as like terms. So how I describe this to somebody, I know this is going to seem a little goofy. Imagine you had a bunch of desserts that you're bringing to to a social gathering, a family gathering, and you have brownies on this pan, and you have certain numbers. So certain people had brownies here, and there's some that were gone, some that were missing, and then you had another pan of brownies over here, but that it was out of your family cookbook, so they're the same exact brownies. And what you're going to do is you're going to be adding these 2 pans together, because maybe there's some gap here and there's some gaps over here, and you're going to be adding the 2. Well, they're still brownies. You're not changing the labels on them. So the idea is to add you just need to make sure that they're cut the same size so they have the same like terms, and then you just start adding one pan to the other pan and see if it will fill it or get close enough to it. That's basically the concept. I know that seems really goofy to think about in terms of food, but to me it makes sense. Like you want to make them the same size, and then you try to fit them in the pan that you're going to, from one pan to the other pan. That's what you're doing here. You need to add these two pans together. Well, they're not the same cut. As you can tell, the denominators are different. The denominator is how they cut the pan. Maybe they cut them into 32 blocks, or maybe they cut them into 20 blocks total. And the top is how many you actually have left in the pan. So there's a select number left. And so what you need to do is make sure that the pans are cut the exact same, so that when you add them together, they all fit, kind of like little Tetris pieces, and they all fit together perfectly. Well, do we agree the bottoms are definitely different? So this is why I spent a whole week with you on factoring. You need to factor the denominators, break them up. Let's look at the parentheses on the bottoms. So, on the bottom, this is a trinomial, right? That's a trinomial. I'm going to leave the top alone. I don't even care about the top. I'm going to leave it. But the bottom, how do you factor it? Let's go back to the rules that we learned last week. So, how do we factor the bottom? Please.
Would you break them apart?
Yeah, you just break them apart. So what are the symbols going to be in each? Plus and plus, right? Because they're the same. They're both plus signs, right? Because I still follow my rules for trinomials. How do you break up x squared?
X.
X and x, okay. And then how do you break up the 8? Two numbers will multiply to give you 8. 4 and 2. And that will give you 6. All right, so there you go, 4 and 2. Make sense? We broke it up. We factored it. Cool. That's the total number of brownies that the pan could have held. That. I know that seems weird to think about, but there you go. Okay, let's do it the same for the other fraction. We're going to break up this pan. Figure out how many are total on the bottom. I need to factor it. So, how do I factor the other fraction? What do we have down there? What are the symbols?
Addition.
Additions. Again, how we know that? They're both plus, or they're both the same. They're both plus signs, okay? How do you break up the x squared?
X.
X and x. And how do you break up 20?
5 and 4.
5 and 4. Now, why 5 and 4? You could have went 10 and 2, you could have went 20 and 1, but 5 and 4 because that makes 9. So the numbers multiply to give you the 20. I'm going to go the 4 and 5 route so that it will give you the 20 in the back. Or 20 in the back for multiplying, and then 9 in the middle for when you add. Okay, does that make sense how we're factoring all that? Okay, so now, we can definitely see at this point, the denominators, the pans, were not cut the same size. The pans are definitely different. So, what do we need to do? How do you make common denominators? Anyone remember from Algebra 2 days? I don't even know if you got to this part in Algebra 2 days. Maybe you did, maybe you didn't. I remember in Algebra 2.
Use something with x plus 4.
Yeah. So, do you notice how both denominators have x plus 4s? That's a common denominator. Now, do you notice that they also, both fractions, have different things? They have like an x plus 2 and an x plus 5. You want to make the denominators all the same. You want to make the fractions have exactly the same bottoms. So what I'm going to do is I'm going to leave the x plus 4s where they're at. Right? Boom, boom, boom. And now what I'm going to do is I'm going to add other parentheses so that they all have the same items. So obviously I want both of them to have an x plus 2. Because this one had an x plus 2, so that one better have an x plus 2. And I want both of them to have x plus 5s. So again, I'm trying to make sure that the denominators are the same. So I'm looking at all the different parentheses that I see and make sure that they all have the same number of them. So if one of them has a couple of 4s, you want to make sure that they both have a couple of 4s. They have to have the exact same number of items on the bottom. Do you see how I did that? I just kind of looked at everything and made sure everything was on every bottom. Now, this is the tough part. Not up to now. Right up to now is just factoring. You guys practiced that all last week. Now the tough part comes in. What did I multiply on the bottom of this fraction that was new? What was new?
X plus 5.
X plus 5. You have to multiply that to the top. Whatever you get on the bottom, you have to multiply it on the top. You have to multiply it to the top because you introduced it. By multiplying it to the top, these could technically cancel out because it's the same and it would turn back into the original product. Don't cancel them, you're just going back to right where you started. So does that make sense now? Or it's like we're multiplying by a number 1. We're just making a really fancy looking one. Bless you. Okay, on the other fraction, what did we introduce that was new? X plus 2. We have to multiply that to the top. Multiplied by x plus 2. That was new. We have to multiply that. All right. I'm going to slow down now. Sorry, I'm going really fast. Is there any questions with how we made the common denominator or how we introduced the new stuff to the top that suddenly became new? Now, the bottom, when you add fractions, what happens to the denominators on fractions when you add? What happens to fractions when you add them, the denominators specifically? Anyone know the rule? How you add fractions? What happens when you add the two fractions together and they have the same denominator?
They stay the same.
It stays the same. So your denominator will stay the x plus 4, x plus 2, and the x plus 5. That is going nowhere. That's how you add. You only add the top. The bottom, since the denominators are the same, it will stay the same when you add fractions or subtract them. Now on the tops, I have to add straight across or subtract straight across. Well, this is the tough part, right? This is the part that you have to do off to the side or you have to do pretty well. We have to add one side to the other side. Like that. Okay, now, this type of problem, I made it up on kind of purpose, but this point, this type of problem is now, well, we're almost done. We now got to a point where we have to mix all the types of factoring. Do you notice, what type of factoring did we do earlier? What type was this? Trinomials. Sometimes it could be a difference of squares, sometimes it could be a cube rule, could be a grouping method, it could be anything. But we did trinomials earlier, okay? We changed the denominators, changed the tops, we added. Now when you get to here, now what you're looking for, and this works every time, what you should look for, now you're gonna look for grouping on the top. And I know that seems really goofy, you're gonna look to group the top. So I'm comparing the left side and the right side. What do they share in common? What do they have? X plus 5. I'm going to rip the x plus 5 from the top. The denominator didn't change. Typically on some of your problems you're going to do in the book, they will always look like this. You're going to take out the common factor out of the top. They usually will have something in common. Just that's kind of how it works. If it doesn't work that way, where maybe you didn't notice the tops had anything in common, like the parentheses were all different, that becomes more difficult. Then you're gonna have to FOIL and then add all the like terms. I'm not gonna do that. This is just easier. What's left if I ripped an x plus 5 from the top on both of those? What was left?
3x plus 2.
3x minus 2 plus x plus 2. Does everyone see that? When the x plus 5's left, those are the two items that were still left over. When the x plus 5s went to the back. When I ripped them off. What happens when you add those together? The 2's cancel, right? And what's 3x plus x? 4x. So here's your final answer. And we can simplify at this point. gets to this point where it is 4x in that parenthesis, because the 2's canceled and the 3x and the x added together. That is a 4x, or that's a really bad 4. 4, there you go. 4x, and then we have the x plus 5 on the outside, and we have on the bottom the x plus 4, the x plus 2, and the x plus 5. Now, this is where, if earlier, maybe you didn't notice they had anything in common. Okay, maybe there wasn't anything in common, so you couldn't do that whole grouping thing. So you had to just like foil this out, add the whole top together to make this crazy thing on the top. What would have happened is you would have had to try to factor that thing apart to get to this part where you have parentheses. It would have worked out to be just like this if you'd done it correctly. What do you notice the top and bottom still have in common? Those can cancel. And you can only do this at the very end, the very last step. And you can only do that because everything is being multiplied together, so things can cancel and divide off. If there's any plus or minus signs in between the parentheses, you can't do this anymore. But since all the parentheses are being multiplied together, those can cancel, and this is your final answer. All right, I'm gonna let you write that down just for a second. All right, now, why are we doing this? Like, why are we getting to this point? What the whole point of this? All right, we got this, the final answer, right? This is what we need to get to for the next section. Because the next section we're going to be doing is graphing functions. It's like putting it to a graph. Super simple stuff. Now, obviously you're looking at this stuff, and this stuff is probably the most difficult part of Algebra 2. It is. It's the hardest part of Algebra 2 when I went through it. Is you got to learn how to like factor things apart, be really good at factoring, knowing when to spot rules or when you should just FOIL and add things together. If you would have FOILed these together and added, you would have got to a point where your top would have just looked like this. This is what it would have looked like on the top. If you were to FOIL the top together and added like terms, it would have came down to something like that, and you would be able to factor it to this. So there's different ways of doing this. I just think factoring is the easiest way. It prevented me from foiling, so I don't mess anything up. Adding like terms, that's a lot of extra steps, as opposed to just factoring. That's why we learn factoring. Makes problems a lot simpler, quicker, right? And then this is the point where we're getting to the next section is, can we graph something like this? This is not a linear function, right? It's not a straight line. Sometimes these can have curves. Sometimes these types of problems might be, they might have asymptotes and little things that we need to learn in the next section where we're going to learn the basics of graphing, random polynomials. You guys have learned rules throughout Algebra 2, you know, how to graph functions. Well, I'm going to give you the crash course on how to graph anything and the shortcuts to do it. So you can have that image in your head what this thing should look like. And we're going to learn that from multiple sections. Be like 3 or 4 sections where we just learn little pieces at a time. But we need to get this stuff down. This is like sometimes the beginning of the problem that we have to do. We have to simplify it so we can get down to what the problem is actually supposed to be. All right, questions though. I'm only gonna do one more problem. That one took a little bit longer than I was expecting. I'm gonna do one more problem. I'll give you guys choice. You wanna do a multiplication or a division problem? Division. Yeah, let's do division. So we're gonna do division. Sorry, that's the majority I heard. Okay, we're gonna do a division problem. I'll try to make it a little more simple than this one. Sorry, I'll try to make it a little bit easier.
7 steps.
Yeah, not 20 steps like this one. Sorry,
This one was 7.
Yeah. Well, I'm gonna make it a little bit easier than that.
7 times
So.
like.
Is this one of the harder ones?
Yes.
Oh.
The addition and subtraction problems are the hardest types of problems you can have.
I was gonna be like, oh, this one.
No. So multiplication and division are actually, multiplication and division are probably the things that are, probably I would say the easiest things to do is multiplication and division. Addition is super hard. It's just, when you see in Algebra 2, they just like, they make it one section long, and they don't even fill in like what it's used for, and they don't talk about all the basics on it, like what I was showing you what you're supposed to do. They just say, okay, factor, and just kind of go from there and add like terms. They don't tell you anything specifically. Well, that's what we need to learn in here. So let's do one more example. We're gonna do a division problem with rational expressions, division-based problem. Let's go with x plus 1 over x squared plus, let's go with 4x plus 3. And we're going to divide by 2x and an x squared minus 9. And you'll see this problem is significantly easier than the last one. Addition is one of the hardest things. You have to get common denominators and change the tops and add across and like simplify it. There's too many steps. Okay, do we notice that this is a division problem? Hopefully your vision can see that. It's division, not addition. It is division. Okay, here's what you need to do before you start. I know some of you are still writing, that's fine. When you first start, you need to identify the operation in the middle. So if it's addition or subtraction, you have to get common denominators. And that's where you have to factor the bottoms. On division, like this one, you need to get rid of the division problem. We don't divide fractions. It's actually incorrect in mathematics. So what we do is we change this to multiplication. And there's a little rule when you switch this to multiplication. When you do that, the second fraction needs to flip over. It becomes the reciprocal. Okay? So the second fraction is going to turn out to be this. Now, if you don't like that little time symbol in the middle, maybe you want to make a little dot, that's fine. That means multiplying anyway. You can put parentheses for all I care. But you change the division sign to multiplication, and you flip the second fraction over. You only do that on division. Got it? The only division problem you'll do this. Flip it over. The first fraction stayed the same. It's only the thing after the division sign. Okay. Are we good so far? Okay, and I said this one is way easier than the last problem. I guarantee it. Okay, now, we still have to follow some of the same rules. We still need to factor everything apart if we can. So, top, bottom, right? So is there any way I can factor this thing apart any further? No. X plus 1 is going to stay. Okay, it's just going to stay in a parenthesis. There's no way to factor its prime. It's not like they have x's in common, or there's not a difference of squares or cube rules, nothing. Okay? The bottom down here, how do I factor that? Trinomial rule. You're absolutely right. So it's going to be, what, plus and plus. Break up the x squared to be what? X and x. Then how do you break up 3? 3 and 1. That makes the 4 in the middle. That makes sense. We'll make 4. Okay, so there you go. That's the factor of that thing. Upper right corner. How do we factor that thing?
Difference of squares.
Difference of squares, yeah. It is a difference of squares. So difference of squares is plus minus. You break up the x squared evenly, and then you break up the 9 to be, what, 3 and 3? And then, can I break up the 2x on the bottom? No, it's just it's not even it's just a monomial. You don't really do anything with those. It's not even a binomial or anything like that, so I'm not looking for difference of squares or cube rule or common factor or nothing. Okay, following with me so far. Sorry, I'm going really fast. I'm trying to make this the last round of the day, so you have a little bit of time you can work it. Okay, we're good so far? Okay, now the last step when you multiply fractions, you cancel things out up and down. So if there's any parentheses that work up and down, you cancel those out. So can I cancel anything out top and bottom?
Yeah.
X plus 1s. Those are gone. Boom. Cross them out. On the other side, and it doesn't look like there's any parentheses there in common. The 2x is in a parenthesis, by the way. Sorry. All right. Is there anything diagonal that can cancel?
X plus 3.
X plus 3s. Those are gone. Because those cancel diagonally.
So then all you're looking is x minus 3.
Exactly. You go straight across, and all we're left with is your final answer. X minus 3 over a 2x. That'd be your final answer.
Way easier.
Way easier. Because on multiplication division, you're always looking to cancel things out right away. On addition, that's the hard types of problems. That's where you have to get common denominators and figure out how to add across or group factor. There's just way more rules that you don't even think about. Question.
So the multiplication division are the same thing?
Yes, they're the same. The only difference with multiplication division is on a division problem, you have to switch it first and then switch that fraction. If this was multiplication, you wouldn't have flipped anything. So, all right, questions. We're done for the day. That's it. Homework, I'm gonna put it on the front of the board here just so you can see it. This is the assignment I handed out last Friday. It was page 65. This is due tomorrow. It's numbers 40 through 48 evens. That was difference of squares problems. Then you had 57 through 63 odds. That was cube rule. And then the last one is grouping, 71, 72, 85 through 87. And that was all on those. So, it's due tomorrow. Try to factor. Question?
Can I go get my book?
Yes, you may.
Somebody some chess.
Sure. Finish out your problem.
Hey, Ward, can we do a grouping?
Yeah. Did you get that first time then?
What first?
The one before this?
Was you Friday?
What's your,
It's 85 or 86. That's the one on both, but they're really similar, so it doesn't
Okay.
matter.
Alright.
Can I come?
So just pick one and tell me what you get. What you
I
want.
don't think I need
Let's
to
do
write.
it.
X squared minus 12x
I don't think
plus
mine makes it,
36
but I'm not finished
minus
with it.
49y squared.
Was how far I saw that.
Yeah.
Like that. Is there any other items?
No.
There's no other Y's?
No, that's why it was confusing.
Yeah, that's a weird one.
And the other ones.
86 is just like.
Yeah,
it,
that's
too.
why they're like the same and I didn't get it.
You can make part for the
So I didn't know how to break it up because it didn't go very far.
Yeah, it doesn't go very far. My instincts are to group that and that together.
Until last time.
That's what I tried, but then I didn't.
So it won't go very far. So maybe these are just primed the way they sit.
Yeah.
Yeah, it doesn't look like you can group this too far. So if I group those together, just because even if I group these, those won't have any x's in common. And I'd be looking probably for 7 there. I think this is the best way to do it. So then you have a difference of squares up here. That's plus minus x and x, 7y and 7y. And then back here, you're going to take out a negative 12. So that's an x minus 3. And that would be it. You couldn't even go further. That'd be the final factoring. Like there's no other grouping to do.
Okay.
That's weird. Yeah, it didn't go very far.
No, I was very confused.
Yeah,
I saw you.
that's odd.
I didn't even see you.
Yeah.
And the thing's imposter. It's like more.
Yeah, that's a little odd. Usually they go a little bit.